This video is on finding the derivative using the limit definition. So when you're finding the derivative, we have a function x squared plus 2x, and what we're trying to do is find a slope generator for this particular function. The definition of derivative is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Now, keep in mind that this formula is really just a way to find slope. It's the instantaneous rate of change. All right, so now we do the algebra. So we have the limit as delta x approaches 0 of, for this particular function, we replace x with x plus delta x. So we have x plus delta x squared plus 2 times x plus delta x. So that takes care of this part of the formula, minus the actual function. Don't forget to put parentheses or you will end up with a careless mistake. And all of that over delta x. All right, now, another thing that students often forget is to bring down the limit as delta x approaches 0. That is very important. You can't leave that off. All right, so doing the algebra and distributing all over delta x. This is when everything starts subtracting out. So the x squares are gone, the 2x's are gone. Still haven't found the limit, so I still have the limit as delta x approaches 0 of, I'm going to factor a delta x out of every term, so that leaves me with 2x plus delta x plus 2 over delta x. The delta x's will divide out, and now I'm actually going to find the derivative by substituting 0 in place of delta x, and since I'm finding the limit, now I don't have to write that anymore. This is my slope generator. So it simply is a formula that will find the slope at any point on that particular curve. So let's say that the parabola that we're talking about right here, let's say that this is x squared plus 2x. This slope generating formula will find the derivative at any particular value of x that I want to consider. Okay, so let's look at the second part of this question. The first part was to actually find the derivative. The second part, part B, is to actually find the slope of the line tangent to the function at negative 3, 3. So let's just say that this point right here is negative 3, 3. I am looking for the slope of the line tangent to that curve at negative 3, 3. Well, if I want to find slope, it makes a lot of sense to go to a slope generator. And so when I find that slope, since my derivative was 2x plus 2, if I want the derivative at negative 3, so notice that you substituted the x value. There's no place to substitute a y value into this formula. So I get negative 6 plus 2, which is negative 4. So I know that the slope of this line up here is negative 4. So first of all, I found the derivative, which is the slope generator. Then I used the slope generator to substitute in the value of x, and I have the slope. Part C is asking me to write the equation of the line that's tangent. So notice that I know the slope of my line, that's right here. I know the x and y value that's given. So, to write the equation of the line is very simple. I'm going to use the point-slope form of a linear equation. I'm going to substitute 3 in place of y1. The slope from the preceding part is negative 4. And the x value is negative 3. So that is the equation of the tangent line to the curve at negative 3. It's the equation of the line that we looked at just up above. All right, let's take a look at the next problem. We are trying to find the derivative of the g function at a particular value, negative 1. So we have this cubic function, and we're trying to find out the slope of the line tangent to the curve at negative 1. So the first thing I have to do is find the derivative. If I'm going to find the derivative, I'm going to write down the formula. So I have the limit as delta x approaches 0 of, in this case, g of x plus delta x minus c of x over delta x. So that will be, remember to bring down the limit because we haven't found it yet. In this case, that'll be x plus delta x cubed plus x plus delta x squared minus f of x, which is the original function, x cubed plus x squared, all over delta x. Now when you're cubing a function, there's no little shortcut like square the first, double the product, square the last. But if you remember your Pascal's triangle from last year where you had 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, you'll remember that this gives you the coefficient of the terms of a binomial that's been cubed. So when I multiply, or when I expand this, and you could do it by multiplying these x plus delta x 3 times, but when I expand it, I'll have 1x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Now squaring, I get x squared plus 2x delta x plus delta x squared. Let's get rid of this over here. Okay, minus the function, which is minus x cubed minus x squared all over delta x. This is the fun part. Everything starts subtracting out. X cubed, x squared. Everything else has a delta x in it. So I'm going to factor out delta x. That'll leave me with 3x squared. So that takes care of that one. Plus 3x delta x plus delta x squared plus 2x plus delta x over delta x, which divides out. Now I can substitute 0 in place of all of the delta x's. And when I do, again, notice here I'm finding the limit, so I don't have to write that anymore. I get 3x squared plus 2x, which is my derivative, so this is equal to g prime of x. It is my slope generated. The problem, the ultimate question was find the derivative at -1. So if I want to find the derivative at -1, I'm going to substitute -1 in place of x. Which will give me 3 plus, wait, something happened wrong here. Oh, I'm getting -1. So I get 3 minus 2, which is 1. So the derivative, or the slope of the line tangent to the curve at -1, that line has a slope of 1. So that's basically how you find the derivative using the definition. Make sure that you complete these 3 problems in the homework. This one in particular, number 33, you're going to have to think about that one. While I'm thinking about that problem, let's go back to the last problem for just a minute. And I'm going to add a question to that problem. Let me get rid of all the stuff that's on here. Clear the annotations. Alright, so in our work we already figured out that the derivative of this function, this was f of x, we already did all that work to find out the derivative of this function was 2x plus 2. What if the question was find the point on f of x where the slope of the tangent line is 10. So the question is, what in the world do we do here? This time we're looking for an x value. We don't have an x value to simply just substitute into the slope generator. This time we know the slope. This is the slope. So I'm not going to substitute 10 in place of x. I'm literally going to set the slope generator equal to 10. So I get 2x plus 2 equal to 10. Subtract 2, divide by 2. And x is equal to 4. So now I know that on this function, when x is 4, the slope of the tangent line is 10. It did say find the point. So I have the x value of 4. To get the y value, I go back into the original equation. So 4 squared is 16, plus 8 is 24. So on this parabola, at the point 424, the slope of the tangent line is equal to 10. So keep that in mind when you're doing problem number 33. That's kind of an idea that's going to impact that question.
Now, do your work.